Welcome to the video guide for your FARO Focus 3D laser scanner. We're at Schloss Favorita in Ludwigsburg, the castle built in 1717 by the Duke of Württemberg. Our task is to fully document this Baroque royal palace in 3 dimensions. The building is characterized by, among other things, a variety of sculptures integrated in the facade, as well as richness of detail in the design of the roof. With conventional methods, it would take a lot of effort to measure this building. The new FARO Focus 3D laser scanner is the ideal tool for solving such complex measurement tasks. The measuring instrument creates photorealistic, 3-dimensional images of real-world objects. The rotating laser of the scanner surveys touches, in the truest sense of the word, its surroundings. The laser beam is used to measure the distance to the object and, together with the device's rotation angle data, determines the coordinates in space. Several million of such 3D coordinates result in a complete 3-dimensional impression of the surroundings. But the FARO laser scanner is more than just a professional measuring instrument. In addition to its compact dimensions, easy transportation and setup, it's characterized by a very intuitive and easy-to-understand operating concept. The integrated digital camera also takes photorealistic color scans. All these qualities enable the FARO Focus 3D laser scanner to be used flexibly in a huge variety of fields. After switching on and powering up the scanner, you can immediately start scanning without any further preparations. The Start Scan button appears in the center of the touchscreen operating panel. Simply tap it and the scan starts. First though, we want to look at the current settings on the pull-down menu of the home screen. This shows both the project data and the active profile with the associated scan parameters. These consist of the resolution and quality, the status of the color option, and the expected duration of the scanning process. You can now either change the profile or adjust the parameter settings directly from the menu according to your needs. For example, the quality can be reduced somewhat in order to accelerate the scanning process. The scanner can now be started. The LEDs on the unit light up in red while the laser is in operation. The display shows the current progress. The entire surroundings have been scanned after a 180-degree rotation. Depending on the settings, the scanner continues to turn, saving the color photos using the built-in digital camera. The device may then make a further rotation in order to calibrate the inclinometers. A tone indicates that the scan is complete. The result is shown on the display. You can enlarge the picture and look at specific areas in more detail. The scan data is stored on the SD card. When the on-site scan is finished, turn off the unit and pack it in its carrying case. That's how easy it is to work with the new FARO Focus 3D laser scanner. But now back to our original task. In order to make a complete 3-dimensional recording of such a structure, it is of course necessary to carry out a large number of scans from different positions. Therefore, we brought along the following material for our scanning work at the castle. The scanner is equipped with an SD memory card, a battery and a power pack with cables for the external power supply. The scanner is usually operated solely on battery power. When the external power supply is used, the battery can be recharged simultaneously. Additional targets are necessary for our project. To maintain an overview of all the necessary scans, the project should be carefully structured. We recommend that you group associated files in project folders. This folder structure can be created directly on the scanner. The more elegant and somewhat more convenient variation, however, is project preparation using the Scene program, which is also used for registering and analyzing the scan data later. Folder structures and the basic file names used by each project are defined in advance. In this case, it's a good idea to distinguish between the exterior and the interior scans. For the interior, further story-based subdivisions can be made. A profile can be created as well as the project structure. A profile contains the parameter settings for the actual scan. Again, the entries are made directly on the scanner or with the scene software. Resolution and quality are the main parameters that determine the file size and scanning time. The option for color scanning plus certain filter settings complement the scanning parameters. A project created in this manner is then called up by the SD card on the scanner. In order to obtain a complete overall result, we recommend that you walk through the object to be scanned in advance and specify the corresponding scanning locations. A floor plan of the object is helpful in specifying these locations. For projects consisting of multiple scans, the aforementioned targets are necessary as reference objects that allow the subsequent assembly of the individual scans to an overall point cloud. For precise assembly, there should be 4 to 5 overlapping targets in the neighboring or subsequent scan. Targets can be balls or paper printed with a checkered pattern. After all preparations have been made, you should now position the tripod on the first scanning point. The height of the scanner should be chosen so that the field of vision covers as much as possible of the object. Now, many more scans are made to capture the castle from all necessary angles. The scanner cannot be turned off or removed from the tripod during transport from one scanning point to the next. Simply ensure that the scanner is carried upright and avoid shocks and impacts. After you have completed all scanning work, press the power button to turn off the scanner. The unit is off after the LEDs stop flashing. The scan data is stored on the SD card. Back at the computer, the collected data is processed with the FARO Scene software. To register, that is, to assemble the individual scans, first import the data from the memory card to your hard drive. In order to do this, open your Scene software and put the SD card with the scans into your card reader. Scene will automatically recognize the SD card and will ask you whether you would like to import the data on the card. Confirm this. The scans will now be copied from the card into the project folder on your computer. The project structure created in advance is now available in Scene and helps to maintain an overview. It also facilitates the registration of the individual scans to a comprehensive 3D model. After recording, the single scans do not have any spatial relation to each other. The process that establishes this spatial arrangement is called registration. In a first step, we have to recognize the references in the scans. Corresponding references are being identified. This can be done automatically by the Scene software. In this example, we show the use of spheres as references, but it's also possible to use corner points or other distinctive points of the scans. The final step uses the corresponding references to determine the position and orientation of each scan in respect to each other. The registration is completed. In Scene, you may use the Pre-Process Scans function for these steps. This function can be found in the context menu of the scan folder via the menu listing Operations. Let Scene search for corner points and other distinctive points, as well as the checkerboard targets and reference spheres which have been used while scanning. If you have scanned in color, as we have, you can carry out the colorizing of the scans here too. All these operations are then carried out automatically to a large extent, as well as the following registration of scans. Depending on the number and size of the scans, this can take from a few minutes up to several hours. You might have to help with the registration and manually detect references which have not been recognized by the software, or you might have to correct inaccurate correspondences. For this, you can use the correspondence view that can be opened in the context menu of the scan folder via the menu listing View. With the help of this view, you can move and rotate individual scans to get correct correspondences of their references. With these corrections in place, registration can finally determine the correct spatial relation of the scans. The result is a registered point cloud of the scan object. With the help of numerous scene functions, additional geometric measurements of all types can easily be performed in virtual space. The point clouds can be transferred to a CAD program such as AutoCAD and used as a basis for modeling. Our task is now finished. Schloss Favorita in Ludwigsburg has been scanned completely and is now available as an authentic digital 3D model.